Okay, welcome friends. I'm going to talk in this video about overloading operators. Now you may notice that C++ allows you to overload operators like plus, minus, and so many different operators that you can overload. There are certain operators that cannot be overloaded. However, it's useful many times to overload operators. I'm going to use my example class here for overloading operators. My example class only has a dynamic or a integer pointer, which I'm using to create a dynamic object. Whenever we create a object of example class, we are creating a integer pointer or a new dynamic integer, which is pointed by the pointer variable. Okay, so we do have a few constructors here. The default constructor, a constructor that a copy constructor also, and a print method, and also a destructor. Now there are two ways we can create overload an operator. One is we can do this when the overloaded operator, we write the definition of the code or the definition inside the class itself, or we can do this outside the class. When we do things outside class, things are a little complicated because we need to get access to the value here, and we can do that by providing a integer or a accessor method to get the value, which is not a big deal. We can always do that. However, it's always nice to, when we are working with overloading operators and so on, it's sometimes helpful to do things in an easy way, which is so that we don't have to call the accessor methods and so on. And we can do this again two ways. One is by using friend function, so we can still write the definition outside the class and make the function a friend. I'm going to talk in detail about this later on. For now, I just want to introduce this very quickly. So I'm going to write the code for the for overloading an operator, which is a member function. So now so to do this, first thing is we need to know how we overload an operator. Now we know that when we create an operator, and I'll show you this code here, and for now I'm going to create this as just a simple object. So example, my object 1, which contains a value 4, and also object 2, which contains a value 7. Okay, so now I can say object 1.print, object 2.print, and when I compile this code and run, we do see here that the int value is 4, address is this, int value 7, we have a different address. Now if I try to add these two numbers and say object 1 plus object 2, and whatever I have in the left side doesn't really matter. I could have an example object 3. I'll get a compiler error, and the compiler error says no match for operator plus. Operand types are example and example. So what the compiler tries to do is looks for a way to add these two objects. These are not simple integers, they are two objects which of a class that we have created, and so compiler doesn't really know how to add these two objects together. So compiler wants there has to be a function that can add these two objects together and return another object. We don't have to always return the data type as the same object. We could return a different type of object when we add two objects or we overload a operator, but in this case we will just create a overloaded plus operator which can take two objects and then return a new object. Now actually, just to keep things simple, I will create an overload the plus operator here, and by overloading the plus operator so that you can see the symmetry here, and then later on we will make it a member function, which is a little bit asymmetrical, but you will get the idea better by making a function here. So when we overload an operator, we create a function, and I'll talk about the return type in a minute, but just like another function. And you can see here when I type operator, you can see we get options of the operators that can be overloaded. And since we are overloading a plus operator, we overload the plus operator, and now we pass two objects of type example. And as you can see here in the error below, the two operands, the operands means the one on the left and the right, are actually arguments to a function. You can see this plus operation as calling a plus function which takes two arguments. One is this left side and the other is the right side, and these two operands are passed to this function. So if I say here that I have an example object, and we will pass this by reference, and we will call it LHS, which it can be anything, but we will just call it LHS, and also example and RHS. So essentially we are passing the LHS, the operand on the left hand side will be passed as the first argument, and this is the standard way C++ compiler works and treats plus and these operators, and the right hand side is the second operator. Now since we are also not going to change these values, we will also put const here. So this is a good definition. Now we also need to talk about what does this method, this is actually the name of the method, operator plus, and you can see operator is a keyword, and that's how the C++ compiler knows is actually we are overloading the plus, the addition operator, and so that we can add one example object on the left side and with another example object on the right side. Actually we can do this with different type of objects. So we can add left hand side could be a string and right hand side could be an integer, or left hand side could be an example object and right hand side could be a string, or whatever we want we can do. So now we also need to pass or return an example object, so that we know that we are actually returning an object of the same type. And let me remove this semicolon here. Now so we have the basics done here, but we still need to write the code to actually overload the definition of the code. Now when I say LHS dot, you can see I have access to print and the pointer, but I don't have the actual value. So what we need to do is this, we need to create and that's what I was talking about. Actually I will show you that we do need access to the pointer value. So ideally what we will do is this, LHS dot pointer, so this is gives the address, and then we dereference it, and I'm just putting this parenthesis for clarification. So we take the address, we dereference them, we get two integer values, so we will say this is the result, and then the new object that's being returned is actually we will create an example object, we will call it, let's say, object, and this is a new int which takes the value result. So essentially, and then we return the object that we have created. So essentially what we are doing is we are taking two example objects, taking the values of those two objects, the integer values, adding them together, and then we create a new integer, and then we actually just example object result. So we are creating a new object example which is uses the value for the result, which is the sum of these two numbers, and then we return that object. So this should work fine if we have access to these values, which unfortunately we don't, because these are private members, and that's what our compiler will tell us, that on line 8 you can see the pointer is private. Same thing for line 19. Now we see that the other error has gone away, which we saw earlier, that there is no plus operator. So we do have a plus operator now, but the problem is that we don't have access to these values. So one way is to create I'll start with the basic. The most simple workaround is that we create a method which is an accessor method, which returns an integer value instead of a pointer. So let's say it returns an integer, and I'll call it get value. I'll call it int value, and this get int value. Actually, let me convert it to camel case and refactor at definition here. So we will return star pointer. So you're returning the integer value. And now in main, what I need to do is, I'll keep this code for now because we will reuse this code, but what I need to do is int result is equal to LHS.getIntValue plus RHS.getIntValue. Okay, so we also know that when we say const, that means we are promising that I'm not going to change the LHS or RHS, these objects, but LHS and RHS is calling the getIntValue method, and we have not made any promise that we are not going to change the object. So we need to put a const here that is essentially promising that I'm not going to change the object itself, and the program should compile fine now. So now we can see there is no compiler error. And actually, let me also print object 3 now. So object 3 dot print. So when I run this code here, you can see we are just line by line. So we are creating two objects. We have int values, and then you can see here the example class 1R constructor is called when we actually create on line 10. And then you can see we do get int value equals 11. This is what we wanted. We are adding the 4 and 7, we get 11, where we actually are adding two objects by overloading the plus operator by ourselves. So that's a great thing, a great feature of C++. Now you can see this is a little inconvenient, especially if you are trying to do a lot of things. Let's say if you have a vector or something, and you want a vector of pointers or an array of pointers, and you want to get access to all the values in the array, then that could be very complicated. And so therefore it might be a good idea that if we could, this function could get access to the private variables, and for that we do have a friend function. We can make this a friend function. This is another feature of C++, where in the header file we will say that we have a friend function, which is this. So this line, which is inside the class, is telling that somewhere we have a definition of operator plus, and this definition is not in the class, but we want this function to access all the private members, which means also the private functions if we have any. So now if we go back here, and now we know that in the main function that this function operator plus is a friend of the class example, so it has access to the private variables. So now instead of this line we could use this we could use this line, and now the compiler should be happy. And now you can see this function operator plus, it's outside the class, but it has access to the private members. And you can see my code compiles, and we can run it. It runs exactly the same way. 4 and 7, we can see here 11. Okay, so that's about friend functions and also about overloading operators. Now the other way we can overload the operators, I'm going to copy this code here and comment it here, is if we make the plus operator, or we overload the plus operator inside the inside the class itself, which means that now we know that when we call a function which is a member of the class, then there is one of the objects is passed implicitly, and that's the this pointer, and this pointer is pointing to the object which called the function, right? Now when we call plus, we have two objects that we are passing. One, as we saw here, one is on the left hand side and one on the right hand side. But if this function which we are calling is a member function, then one of the objects is passed implicitly, and then we only need to pass one object. And that's what C++ compiler expects, that when we overload an operator, so the definition will be very similar. So we example operator plus, and now the only difference is that this time we will only pass the right hand side, and the left hand side of the plus, the left operand, is passed implicitly as the this operator, as this pointer. So now we now this is a member function, as you can see, and when we have this dot, so you can see we get access to these values. And now I'll copy the code, and the only difference we are going to make here is, instead of LHS dot pointer, I just need this dot pointer, because this is one of the operands, the left hand side, and RHS is the right hand side. So we are taking the dereferencing the pointer value to get the integer, creating a new object and returning the object. So now when I compile the code here, so now we don't have the plus operator as a non-member function, but now the plus operator is a member function. So when I compile the code now, it builds and it runs exactly the same way. The only difference now is that the plus operator is a member function, and as it is a member function, now we only pass one, the right hand side, and the left hand side is passed implicitly as this operator. I hope that is clear. And now in the next lesson I'm going to talk about overloading the assignment operator, because assignment operator cannot be created as a non-member function as we did for the operator plus. So that's the restriction on assignment operator, that it must be a member function of the class. Okay.